This is video number 2 of section 1.5a, and now we're moving on with the product rule. So with this rule, if you have a base with an exponent inside brackets and then another exponent outside the brackets, the exponent outside the brackets multiplies the exponent inside the brackets. So it doesn't add here, it multiplies. So here is our first example. So we have 3 to the 5 inside brackets, and then we have an exponent of 4 on the outside of the brackets. So this 4 is going to multiply here. So we can draw a little arrow to show that. So we get 3 to the 5 times 4, and 5 times 4 gives us 20. So we have 3 to the 20. Another example, very similar, but here we have a base of a letter of x. So we have x to the 8 times 2. So this multiplies here, and we get x to the 16. Which leads us to our next rule, a product to a power. So this is the same, except it says if you have multiple bases inside your brackets, so here we have a and b, two different bases, then the exponent on the outside of the brackets multiplies each base. So here's our first example. We have it one base is a 3, another base is an x. So this 3 is going to go on the 3 and on the x. So it's going to multiply here and here. So we get 3 to the 3, x to the 3. And then when we have a mix like this of a number and a letter, we like to simplify the number. So you put 3 to the 3 in your calculator, and you get 27 x to the 3. So the next example, we have 3 different bases. We have 2, x, and y. So our 4, exponent 4 here is going to go to the 2. It's going to go to the x. It's going to go to the y. So we get 2 to the 4, x to the 4, y to the 4. And then we can put 2 to the 4 in the calculator, get 16, x to the 4, y to the 4. And I'm just going to do one further example, C. Let's say you have bases that already have their own exponents. So we're combining this and this. I just want to show you an example. So let's say you had 2 to the 2, x to the 3, and y. And let's say that was to the 2. Okay, so what you would do here is the 2 multiplies here, here, and here. So you would get 2 to the 2 times 2, x to the 3 times 2, and then y to the 2, since it had no previous exponent. So you get 2 to the 4, x to the 6, y to the 2, and then 2 to the 4 would be 16, x to the 6, y to the 2. All right? So that's if your bases have their own exponents already, then you're going to multiply like you did in the power rule. So in a lot of cases, as these questions get more complex, you need to combine rules together. So the next rule is a fraction to a power rule. So here it's saying if you have an exponent on the outside of a brackets and inside your brackets you have a fraction, the exponent goes on the top and bottom of the fraction. Okay? It's very similar to this last rule that we learned, because basically it's saying the power goes on all the different bases. It doesn't matter if it's in a fraction form or not. So here we're going to say that we get 4 to the 3 and 5 to the 3. And then you can put 4 to the 3 in your calculator, you get 64. You can put 5 to the 3 in your calculator and you get 125. Here's another one with just with letters. So this 4 is going to multiply on the x, and it's going to multiply on the y. So you get x to the 4, y to the 4. So the last rule that we're going to learn today is the powers with negative exponent. So if you have, oops, I'm just going to move this up. Here, for example, we have a base of x, and then we have our negative exponent is negative n. So to get rid of that, we are going to flip our base. Now, because this base, there's no fraction, it's over 1. When we flip it, a 1 appears on top. Okay. Here, if we already have a fraction, so there's not just a 1 on the bottom, it's an actual number. When we flip it, whatever the number was on the bottom moves to the top, whatever number was on the top moves to the bottom, and the negative disappears. Okay, we've already learned about reciprocals. Remember, before we were talking about negative reciprocals. These are just regular reciprocals. So basically, a reciprocal is just this flipped fraction. So any whole number is always over 1. So if you're going to flip this whole number, it becomes 1 over 4. Here you have 2 over 3. The reciprocal of that is 3 over 2. Okay, so here, to get rid of a negative exponent, we're going to flip it so it becomes a reciprocal. So let's look at an example. Here we have 3 to the negative 2. So we know that 3 is a whole number, so it's always over 1. So we're going to flip that fraction to get rid of the negative. So now the 1 moves to the top, and we have 3 to the 2 on the bottom. And the 2 loses its negative sign. We can then further simplify this. You can put 3 to the 2 in your calculator, and you get 1 over 9. Now, before I move on to these examples that have more complex negative signs, I just want to show you a couple more examples down below. So I'm just going to draw a line here. Where am I going to do them? I'm going to do them off to the side. So A, B, C, D, I'm going to call this E. So if you have, let's say you have this. So here you have a base with a positive exponent or no exponent. So here it's like we have a 1, right? So it's positive. And here we have a negative. We only flip the base with the negative exponent. So the 2 is going to stay where it is. It doesn't move. And we only move this. We're going to move it to the bottom. So we get x to the 3. So if you have 2 bases, you're only moving the one that has the negative exponent. Let's say you have something like this. 2 to the negative 2, x to the negative 3 over y. So in this case, the y is going to stay where it is. These need to move. So this becomes just a 1 on top. If you're ever moving everything, so if you ever have no bases left on the top, then your default is to write a 1. Then we have 2 to the 2, x to the 3, y. And I'll do one more example here before I move on to these other ones. I'll do G. Let's say you had 2x to the minus 2 over y to the minus 3. So in this case, the 2 stays where it is because it's positive. Let's make it 2 squared. So it doesn't have to be, just so I can show you that it doesn't have to have no exponent. If it has a positive exponent, it stays. So 2 squared. So now this one needs to move down, and this one needs to come up. So here, we're going to end up with y to the 3 over x to the 2, like this. Each base, so this base flipped and this base flipped. Okay, so you don't flip the whole fraction, you move each base individually, and only if it has a negative exponent. All right, so moving back over here to these ones. When you have negative signs, remember going back to the beginning, if the negative sign is inside the bracket, then we consider it as part of our exponent, and if it's outside the bracket, we consider it the very end. So here we're going to, this is like it's over 1, so we're going to, we're going to flip that to get rid of our exponent. So we get 1 over negative 5 to the 3. If you put negative 5 in brackets like that to the 3 into your calculator, you get 1 over negative 125. And then usually a fraction is not written like this with a negative on the bottom. You would write it as with the negative out in front, or the negative, so either they'll put the negative out in front or they'll put the negative here with the numerator. Negatives always float up from the bottom. You never leave them down here. So you can put it in the middle or you can put it on the top. Let's look at another example. So again, we have a negative inside our bracket. So we're going to leave the negative in there. And then we have a negative exponent. So we're going to flip this fraction to get rid of our negative exponent. So 4 over 3 to the 3. Then we're going to have this exponent go with this number as well as this number. So we have negative 4 to the 3 over 3 to the 3, which gives us negative 64 over 27. And then this last example is pretty straightforward. So here we just have a positive fraction with our negative exponent. So we're going to flip our fraction. We get 3 over 10 to the 2. And then this 2 is going to go both on the top and the bottom. So we get 3 to the 2 over 10 to the 2, which gives us 9 over 100 as the final answer. All right, so that ends the notes for this section. So now you're going to go to page 43 and you're going to do number 3, the left-hand side, number 4, the whole thing, and then number 5, A to J. And that is the end of today's lesson, and that's the homework for the rest of this section.